Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P2122 indicates an issue with the Accelerator Pedal Position APP Sensor A, which is integral for understanding throttle input. In this instance, it suggests that the APP sensor's output voltage is lower than a specified threshold, thereby signaling an abnormality detected by the Powertrain Control Module, PCM. The APP sensor is physically located integrated with the Accelerator Pedal Module inside the vehicle, where it plays a crucial role in providing real-time data regarding the driver's accelerator input to the engine management system. This information allows for optimal fuel delivery and engine performance. If the sensor's voltage output dips below the threshold of 0.2 volts, it will trigger this trouble code. It's important to address this issue swiftly to maintain vehicle operability and safety, as incorrect throttle readings can impact engine performance and vehicle acceleration. The DTC P2122 specifies that the APP sensor A's output voltage is less than expected, signifying a malfunction within the circuit. This default voltage condition is registered by the Powertrain Control Module, or PCM, and it subsequently stores the Diagnostic Trouble Code for future reference. The APP sensor's primary function is to transmit data about the position of the accelerator pedal to the engine control unit, facilitating appropriate engine management. This sensor is conveniently located in the accelerator pedal module, making it essential for the vehicle's responsiveness to driver input. When the voltage reading falls below 0.2 volts, it suggests a fault either within the sensor itself or in the connection between the sensor and the PCM. Addressing this issue promptly is key to ensuring the vehicle's smooth operation and driver safety. The potential causes for the DTC P2122 include several elements of both the APP sensor and its wiring. First, a faulty APP sensor, which may have internal defects or undue wear, can lead to the observed low voltage. Secondly, wiring or connection issues, such as a short to ground or open circuit, could hinder the APP sensor's ability to transmit accurate voltage. Such faults can arise from physical damage, corrosion, or poor connectors. Lastly, a malfunctioning PCM could misread the sensor's data, even if the wiring and sensor are functioning correctly. A comprehensive inspection of each component and the associated wiring harness is essential to identify the root cause effectively. Each part must be evaluated carefully to ensure proper functionality and connectivity, thereby avoiding unnecessary replacements. The driver may experience several symptoms associated with the DTC P2122, significantly affecting vehicle performance. One primary indicator is an unresponsive throttle, leading to difficulty in accelerating as expected. Such a situation can cause frustration and could potentially lead to dangerous driving conditions if the vehicle fails to react to accelerator input. Additionally, the check engine light activating is a common symptom, alerting the driver to ongoing issues requiring attention. Engine performance may also be compromised. For example, the vehicle could experience sudden power loss or erratic acceleration behavior, putting the driver at risk. Recognizing these symptoms promptly can aid in timely diagnostics and repairs, ensuring that the vehicle operates safely and reliably. To initiate troubleshooting for DTC P2122, first, turn the vehicle's ignition to the on position, ensuring that all electrical systems are live without starting the engine. This step is crucial, as it allows the handheld diagnostic scanner, known as HDS, to check the APP sensor A voltage. According to the diagnostic manual, readings below 0.2 volts signify a fault condition that necessitates further inspection. By verifying the voltage at this stage, technicians can effectively determine whether an issue exists with the APP sensor itself or its related circuitry. Interpret the data displayed accurately to decide on the next course of action. Should a low voltage be confirmed, it will reaffirm the presence of a fault that warrants additional investigation. For the second troubleshooting step, disconnect the APP sensor connector, which has 6 pins, to begin the physical inspection. The next task is to use a jumper wire to bridge specific terminals within this connector, specifically terminals number 4 and number 6. By doing this, you create a direct path that bypasses the sensor temporarily. Once this connection is established, turn the ignition back to the on position again and recheck the APP sensor A voltage using the HDS. If the voltage reading exceeds 0.2 volts, it indicates that the APP sensor itself is likely faulty, as the components are functioning normally. However, if the reading remains below this threshold, further investigation into related components or circuits must be conducted. This step helps isolate the fault more precisely. After confirming initial checks, prepare to inspect the power supply and signal circuits, referred to as VCC1 and APS1. Before disconnections occur, ensure that the SCS line system is jumped with the HDS, waiting over a minute to clear any residual faults. The next step involves disconnecting both the APP sensor connector and the PCM connector prior to inspecting the circuits. It is critical to check these wires according to the specified resistance requirements. For example, the VCC1 and APS1 circuits should show resistance values lower than 1 ohm. Completing these checks accurately determines whether there are open wires or shorts within the circuit that could contribute to the low voltage problem. Proper execution of this inspection reveals potential wiring issues that may mislead diagnostic efforts. In this step, conduct a detailed examination for any open or short circuits within both the APS1 and VCC1 wiring. Utilize an appropriate multimeter to measure resistance, ensuring that the APS1 open wire inspection indicates less than 1 ohm, while the VCC1 check should yield the same result. Any resistance readings above this threshold would suggest a problem within the associated wiring. Furthermore, check for APS1 being shorted to ground. Acceptable readings should exceed 1 megaohm, 1 MO. These results lay the groundwork for identifying whether the fault resides in wiring issues or component failures. Meticulous attention to these tests can save time and prevent unnecessary replacement of components that are functioning as intended. If all previous inspection steps show normal conditions without notable circuits or sensor failures, the focus shifts to the Powertrain Control Module, or PCM. This component acts as the central nervous system of the vehicle's engine management, processing inputs from various sensors, including the APP sensor. If it's confirmed that all circuits and connections are intact, then it's plausible that the PCM itself is responsible for the low voltage reading. Testing its performance can be intricate, and if found defective, it may require reprogramming or outright replacement, depending on the specific testing protocols from the factory service manual. Steps may involve advanced diagnostics to ensure the PCM functions as intended in relaying accurate data to the engine system. Establishing whether the PCM is faulty is pivotal for restoring optimal vehicle performance. Once all necessary repairs have been completed based on the troubleshooting steps, it is essential to conduct a final verification to ensure the issue has been resolved. This involves confirming that all previously identified faulty components, replaced or repaired, are functioning correctly, such as the APP sensor or wiring where applicable. Following component checks, A road test is necessary to assess whether the vehicle exhibits normal throttle response and that the check engine light remains off. During this test drive, pay attention to the vehicle's acceleration and overall performance to validate repair effectiveness. If symptoms persist or the DTC reappears, further diagnostic evaluation may be required to pinpoint any lingering or new issues affecting the system. Successful validation ensures both driver safety and vehicle reliability after addressing the P2122 error. To prevent the recurrence of DTC P2122, routine preventive maintenance is crucial. Regular inspections of the APP sensor and the connecting wiring harness can identify potential issues before they escalate into overt faults. This could include checking for fraying wires, corrosion, or loose connections that can interfere with the signal integrity. Additionally, utilizing diagnostic tools to assess sensor performance periodically can ensure that it remains reliable over time. Ensuring that all electrical connections are secure and free from contaminants is vital to maintaining sensor health. By implementing these preventive measures, vehicle owners can minimize fault occurrences, ensuring that the APP sensor operates smoothly and efficiently without triggering diagnostic issues in the future. In summary, the DTC P2122 highlights a critical fault condition associated with the Accelerator Pedal Position Sensor A circuit, indicating low voltage that impacts engine performance. Addressing this issue involves a systematic approach to troubleshooting, starting with voltage checks and progressing through extensive circuit inspections. Each component involved must be analyzed and tested appropriately to identify whether the fault lies in the APP sensor, wiring, or the PCM itself. Confirming the integrity of these components through methodical inspections is pivotal in solving the DTC effectively. Awareness and implementation of preventive maintenance practices can further safeguard against future faults. The successful resolution of these challenges ensures not only the functionality of the vehicle, but also the safety of its driver and passengers. Please like and subscribe to the channel. See you next time.